Hello, I'm Rob Hirschfeld, CEO and co-founder of RackN, and this is a Digital Rebar install video. In this video, we're actually going to go through all of the process that you would go through if you're trying to do an install for your own trial. If you want just a fast run through to see how Digital Rebar works, I suggest you check out our smooth run through video where you'll just see the essence of the product being used without actually worrying about the setup and install. I do want to take a second to explain the install environment. Basically, we're running this on a desktop using standard desktop virtualization, Hyper-V for these demos, with two switches, one default switch that connects to the internet, and then a private network that we use for booting and provisioning systems. This makes sure that we don't interfere with your local networking. From there, the Digital Rebar server will attach to both networks. Not only is it our DHCP and DNS server and our PXE server, it is also our NAT gateway in this configuration. And from there, we're able to boot, provision, and run systems through a full lifecycle in this environment. It's a very fast and easy way to test Digital Rebar on your desktop without needing any additional setup. So let's start doing the full install. In this version, we're going to go through in a little bit more detail how you actually build a Digital Rebar infrastructure server. And that's going to start from having our Digital Rebar Alma. I'm using an Alma 9.5 server, which I've already set up and gone through the process of installing on those two NICs. And I'm going to show you the settings very briefly, just so you get a sense of it. What I've done here is I've given myself plenty of processor capacity, fair bit of memory, 16 gigs of RAM, although you can get by with less. And I have two network adapters. The first one is on my default switch, which connects to the internet. And the second one is on my Digital Rebar provisioning network, which is a private network. I can show you over here. These are the two networks I've set up. It's important that in this private network, we have turned off DHCP. So in this network, it is only going to be Digital Rebar, but we're going to use that two network connection to create a bridge. And I'm going to walk you through how to do that and also show you what it looks like if you don't have that setting correctly configured. So let's go ahead and start going through that process. What I want to show you first is you need to know the IP address of that machine. So let me open that up. And then I can just say IPA to get my IP address for this machine. So this is going to be 192.168.50.53. All that's good. I don't actually need to go back onto the machine because when I installed the machine, I uploaded my SSH key and I can just SSH right into it. This is really where the install process starts. And using the install that you can find the details in the Digital Rebar portal page, I'm going to go ahead, copy that in. So this is basically downloading the install process and then running the script to tell it we want to do install using our universal install. And I've added two additional commands in here that you don't need to use. One of them is to define the Digital Rebar ID. I do this so it matches my license file and I get a consistent install. And then to save a little bit of time for you, I've downloaded the zip file so that I don't have to wait and pull that down from the internet. So I'm going to go ahead and take advantage of that not getting pulled down. If you're doing your first install, don't bother with that. The install file is going to download it for you. And what you'll see here is we've gone through the process, taken that zip file, and started Digital Rebar, and it's already running. So what I want to do is I want to slide this over, jump into the system just like it says in the instructions. Go to HTTPS, my IP address, port 8092, but it's not going anywhere. And this is not surprising because I forgot to turn off my firewall on the system. So let's see, let's go back into the system, and I am going to do a couple things. One is I'm going to turn off SE Linux. Great. Easy enough. Then I'm going to set up my firewall rules. So here I'm starting firewall D, and then I'm adding permanent exceptions for port 8090 to 8093. These are Digital Rebar's primary action ports. 53 for DNS, 7879 UDP, so I can do DHCP. And then I have a couple more port ranges, 8080 and 443 for TFTP. So a whole bunch of different ports open to run all the different services that Digital Rebar does, set the zone to public, and go ahead. And you'll notice in the background, if you were watching, that it's already decided to come in. In a trial, we just do a self-signed certificate, so I have to accept that certificate. Perfectly normal. If you're doing a production install, you would take you would install your own certificates, and there's a place in the UX for you to easily do that. Here, I'm going to go ahead and type in the password for the RocketSkate user, and if you don't know where to find that, it's just up here. Show you the default username and password. Definitely, you want to change those things if you're running anything besides the trial. And here, if you're doing a trial, you're going to fill in your username, password, and email. This will let you register for a trial license. Very easy to do. What I've done, since I do a lot of these, I have downloaded and stored my license. Grab my license here, upload it into the system, and continue right on. So now this is giving me the Digital Rebar UX. And I can actually see all of the, this is where I'm actually going to see all of our configuration and health check. Since I'm going through the bootstrapping process, it's actually going to ask me about bootstrapping. And so I'm just going to click right here. Same thing, the Discover Machines takes me right through this new wizard. If you tried Digital Rebar before, we have significantly streamlined the install wizard here, making things a lot easier. And so this wizard will take you through all of the install steps necessary, actually handhold you through it. So here it's going to ask me to upload my SSH keys. I'm going to go ahead and do that. There's my SSH key. I need to create a subnet. This will allow me to pixie boot, which is what we're going to do predominantly in this demo. If you want to try other types of things like image-based deployments or media attached, those are in different demos, require a little bit more skill. So we're going to stick to the simple one. And here you'll see we have 2 ports. This one is my internet port, the one I've logged in on. It's an ETH0 and it has a gateway. That's usually an indication that it's connected to the internet. This machine does not have a gateway. And this is my provisioning network. So I'm going to use that as my subnet. And the wizard's going to pre-populate with everything I need to get running in the system, which is excellent. So all of the settings, including my gateway and DHCP server, need to get set. That's excellent. And then I'm going to go through and check off that box. So this looks excellent. I'm going to confirm there's no DHCP server. Showed you that already. And there is my Ethernet port. Now it's warning me that I haven't set up a DNS server, and I am going to ignore that warning for the moment because I want to show you what it looks like if you forget to do that step. And then here it's telling us the next thing for me to do is power on virtual machines. And before I do that, I'm going to check, because I'm moving really quickly through the system. I want to check to see how I'm doing. This, if I jump over to machines, or if I'm in the provisioning view, these are going to show me that I've got machines that are in process. This vehicle 001 you might remember is my Digital Rebar ID, that name I gave the system, and it is still going through the bootstrapping process. So this is the self-bootstrapper, and it is configuring and setting up a base system for trial. Now, you don't have to do this step, and there are ways to avoid it if you're building a production system, but for a trial, it's really convenient for it to download and set up all the necessary components that you need. Here, it's downloading our sledgehammer image. This is our discovery image that is used when we first boot systems to do an inventory and a deep scan of them. It's an in-memory only system, so it doesn't install the hard drives. It won't break anything that's on your system if you're just playing around. So very handy for that. It takes a little bit of time to download that. And so what I want to do is take a moment while we're waiting to show you. Overview here is going to show you pools. Pools are fair groups of machines. If I have any machines that have failed, I can actually watch and see across my infrastructure what stages machines are in. I can look at cost analysis if I've set up those components, and I can actually get statistics of how long jobs are taking, so I can find potential systems or jobs that are not performing as expected. Alerts would actually, if something breaks or comes out of spec, I can get an alert about it. I can set up or create my own alerts. This is a really handy part of Digital Rebar, especially in unattended or edge environments. Plugins are a whole bunch of add-ins that we use to do additional capabilities from the Digital Rebar server. Inform preferences is where we started. It's a place where you can make sure that your endpoint is healthy, see the different statistics about the system, see how active your systems are, set our hundreds of configuration settings, even check on things like your HA status or upload certificates. License management is to let you see the entitlements for your license. And then we're back to Pixie Bootstrap provision. And Inbox actually allows us to send and receive messages directly from the UX if you want to do things from that perspective. Looks like we are almost done, but not quite. This is downloading Docker containers to run special context in the background. Clusters is a way that you can control groups of machines using our workflow system. Resource brokers allow you to proxy for cloud or machine pool resources as part of a cluster request. Pools are ways to take groups of machines and then treat them as cloud type resources, where you can say, instead of giving me a specific machine, you can say, I need a machine or machines from a pool, and run up an update setup workflow. When you're done, you can release them and then do cleanup actions automatically. So a lot of base capabilities here. At this point, I've probably walked through the system, talked through enough things that you can see that we've completed our activity. These downloads are normal. It's checking to see if it has it and if it go through the process. So we are in a state where I can now go ahead and boot. Really, as soon as that discovery ISO is uploaded, I am ready to go. So let's jump back into our discovery mode. And over here in Hyper-V, I have a couple of machines I've already set up. These machines, let me show you the settings here. These machines are much lighter weight. They have just 4 gigs of RAM. They only need 2 virtual cores, hard drive for me to install operating systems to, and then their only network adapter is that Digital Rebar provisioning network. So with these machines, I can come in here. I actually want to start them where you can see them. So I'm going to go ahead and start. This is the 100 machine, and I'll start the 101 machine. So we have 2 systems in there, and they're going to go through a normal Pixie boot process. One thing to note is, because I have the license installed and the default entitlements, I can use secure boot. So this system is using secure boot in the VMs. It would flash up a red warning banner if I was not doing secure boot. And we have demo videos that show you what that looks like if it's on or off. And if you want to test secure boot, which I highly recommend using secure boot, then you're going to want to be able to see that as part of your provisioning and testing. You should definitely use secure boot. If I jump over to provision now, you can see I have 2 discovered. I have these machines. And what you'll notice is this has started our provisioning pipelines. But in the provisioning pipeline, I can't actually come in and test it. It's telling me it was trying to connect in to do a repo check. That didn't work. We automatically did a recovery action or a retry thing where we're coming in and we're saying, hey, wait a minute, you need to go try this action. It's because the and it's automatically going through and doing connectivity tests to see what's going on and how to fix it. So automatic diagnostics in this, and the systems have both failed. Now, what you'll remember is I didn't set up the DNS server. So let me go back through and get my DNS server going. Before I do that, I actually want to show you what it looks like when I try and do it. So this is my virtual machine interface to that 100 machine, and I can log in. Root rebar1 is the default for the Sledgehammer instance. And if I say ping Google, it's not resolving it, right? My DNS is not set up. So let's fix that DNS problem. I can go back to the create subnet here, and it'll take me to zones. I can also navigate down into my networking section and find zones that way. It's going to work. It's going to take me to this screen in both cases, and go ahead and create a zone. I'm not worried about creating real DNS records like I could do for each machine and interface dynamically. I just need to create a root zone that's going to go to the internet. And for that case, what I want to be able to do is I just need to give it a dot for an origin. Some priority is handy. I want to forward. I'll just use Google's forwarder here, 53. And then I do want it to continue. And I'd like, just for peace of mind, I also add a filter in here. So this is the 124 network. You don't have to add a filter. For me, when I'm sometimes if I set this up in a way that leaks a little bit, this makes sure that the DHCP, the DNS server for Digital Rebar is only answering for machines in that IP range. So just a nice extra safety. Safety is always good. And if I come back in here and ping Google, you can see now I am getting an IP address back for Google. What you'll also notice, though, is that while I'm resolving Google, I'm not actually getting those pings back. To do that, I need to set up my gateway. So let's go back over here. This is my Digital Rebar server, and I need to set up some forwarding rules to make that go. In this case, what I'm doing is I'm using IP tables, and I am forwarding traffic, and I'm going to post these so that you can copy them. You don't have to read them off the screen. You're gonna forward traffic on ETH0 for one rule, and then you're going to tell ETH0 to accept traffic from ETH1. Excellent. And then we're going to set up NAT rules that are going to do routing for that network. And I've actually tightened in the subnet a little bit, so it's going to be the lower part of the range, so 26 instead of a 24, and I'm going to enable routing for the system. That looks excellent. So now that I have added the routing rules, I should be able to go back into this system, and when I ping Google, look at that, I'm actually getting responses back from Google. And if I want to do a little bit better, I can curl Google, and it's going to tell me I'm actually going to get a page back. So at this point, I have now set up Digital Rebar to forward traffic for those systems. So if I go back over here and to these machines, I can actually, let's see, I should be able to come into this activity. It's still trying to do those tests. If I restart the workflow, what'll happen is instead of missing that and going into the alert loop, it's actually testing and checking to get my internet access and downloading those pieces. So common thing for people is to go through and have challenges getting connected to the internet. And then if you can set up a gateway like I've done, then you'll go straight to the internet. If you can't, there's actually instructions in that command also to set package repositories to not go to the internet. And that you can easily accomplish by setting the package repositories. I'll show you what that looks like on this configuration for the machine. I can go into parameters. I can add a parameter, package repositories right here. And you'll see by default, I have a list of package repositories on the internet. What I actually want to do if I want to disable that is just set that to an empty list. And if I do this, then it won't even try to go to the internet. So I can go to restart the workflow. And for this machine, because I've set a parameter here, it's going to completely skip trying to check the internet, where for the other one, it didn't. So you can see how much faster this ran because it just skipped that step. Both are okay. And if you don't want to connect to the internet at all, we have in the profiles section, you can set that parameter for all machines used at the global profile level. So we used to do that in demos, but I really prefer being able to connect to the internet. It's a much more effective way to run the demo. So now that I've gotten that, I'm going to jump back to this provisioning view, which is way up here at the top. In my provisioning view, I have these two machines that are now running. In Sledgehammer, there's a small bug that I believe is already fixed, just hasn't made it onto the portal yet, where these machines are actually discovered. So they would be normally up here. But what I can do in this, I could check a box here, go to provision, and go through the process of choosing an operating system and watching how things go. Some of these operating systems, like the Alma, have online resources. So if I pick the latest or the latest release, it's going to actually download those packages as I go. Now that's going to take a long time to go through and do it. For this one, I'm going to go ahead and do CentOS because I want to show you what it looks like. CentOS does not automatically fetch from the internet, and so it will not complete if I don't include a boot ISO. Once again, common problem that people see. It's telling me to check for a boot ISO. I'm ignoring this, and I'm going to go ahead, continue, and say finish. And when I do that, This machine over here is going to go through. Let's jump to that machine. We're in our activity. What you'll notice here is we haven't even started the install process yet. What we're doing is we're just running through the pipeline in Sledgehammer to prepare for the install. So it's about to go into a process. It's doing all the checks for the system. That allows us to do setup, BIOS configuration, prep, get machines ready, do additional configuration based on the inventory. Now what's happened is we've completed those steps, but the system is smart enough to say, wait a second, you don't have that ISO loaded. You can't start this process. So we need to go and upload some ISOs. I'm going to show you where to do that and how to know which ISOs to download. So if you scroll down in our list, you will find something called boot environments. Boot environments, and we have a significant number of them, are for all of the distros that we have installed pipelines for. And so here, what you'll notice is for some of these, the Alma ones are a great example. I can go and download those sources. Now, these links, because they often get taken down from broad repos, may not take you anywhere. The most recent ones definitely will. So if you're looking for an older OS, you will need to provide that OS. You're going to have to find that boot environment, that ISO, the matching things. But in a lot of cases, you can, if you're doing recent things, then you'll be able to just download here and take that piece. Now, from there, once you've downloaded it, you can go into the boot ISOs and then upload the boot ISOs into the environment. So for example, here, I'm going to go ahead and pull in that CentOS Stream latest ISO. I'm going to go here and then upload that. This is going to take a little while, and I'm going to let you skip forward and check back in after I've uploaded the CentOS ISO and the Alma ISO. So you can see that I was able to download the Alma 9.5 and the CentOS Stream 9 ISOs. The CentOS Stream is very large, takes a bit of time. So if you have a choice, pick the minimal versions of these systems to download and upload. But now that I can come back, I can go back to my provisions view. I'm a little old school. I've been using this new view is really handy for watching systems go through and really helpful to find things that are failing. Some of our customers really appreciate having this very clear. These are available machines, ready machines, and failed machines. If you're used to Digital Rebar for a little while, this is a more traditional view called the machines view, where you can modify these different columns, change things around. There's a little bit more flexibility for experienced operators here. I can come back in here. And for this machine, since I've downloaded CentOS now, I can go ahead and run. And what you'll see is it is going directly into that process. So it's already gone through a start, and it's going to go do a CentOS install. And I can tell you a regular ISO boot install is going to take several minutes to complete. If I want to do the Alma view, I want to show you how to do that one. From this view, I don't have to do it from the provision view. There's a handy button right here. I can go back through and do a provision or a rediscover. I hit provision here, Alma. This was the 9.5 min. That's the ISO I uploaded. Go ahead, click next, review what I'm going to do, finish it, and it'll do what it's done before. This first pass goes through in Sledgehammer, where we're reviewing all those steps, making sure those things go. And then once it's ready and prepared, has everything set, it's going to go ahead and then start the install on the second machine. And so at this point, we're going to have these two operating systems ready to go. One thing I want to point out for this as it works through that process, this is the machine now doing the reboot cycle and starting that Alma install from the ISO. And the CentOS ISO is making progress. It's got a bit to do. But one thing that is handy to hear is that since Digital Rebar has this type of API-driven evented system, you're actually going to get immediate feedback that these systems are offline during provisioning. We know that they're doing provisioning. You can actually see for how long they've been offline while we're waiting for this cycle to occur. And as soon as the system kicks back in, we're going to see the tasks progress. So I can come back in here. I could click here. And as soon as the machines have completed the install, Digital Rebar is going to automatically start back up, run the agent, and then do post-provisioning operation tasks for you. And you would see those come in. You'd also see the status of the machines change in that process. It's going to take a couple minutes to do that. And I am going to let you watch that and then speed up things so that you don't actually have to spend the same amount of time that I'm going to spend letting the systems build. Normally, I'd let these installs progress on their own. If you really want to see this go faster, check out our demos on Media Boot or image-based deployment boot. Image-based deployment is much, much faster, and I have done many image-based deployments simultaneously, and usually they take under a minute. These ISO installs on my system take approximately 10 minutes. Can be a little bit of time for you to wait while the system boots. And then what you'll notice here is as those systems complete their boot cycle, they're going to log in, come out of this wait mode. Agents will check in, and then we will see them restart the workloads and the pipelines. I'll take a second and show you what the pipelines look like while I'm waiting for that reboot to continue. So here, if I was to look through our Alma pipelines, we have a lot of them. And one of the benefits of Digital Rebar is that we do maintain this long history of the operating systems that we support. So there's a lot of upfront capabilities that you get, and you can see in this Alma install pipeline, we can actually look at what's going on with how all the systems and processes work. We even have maps and graphs that allow you to see how the different workflows operate in these systems. So really powerful underlying workflow engine that makes sure that not only do you get great install processes, but those install processes can be extended for your needs dynamically without breaking the base automation layers that we include in the product. So you get the benefit of these well-proven, time-tested pipelines, and then there's injection points where you can add your unique components to it. And as we improve the pipelines, you continually get the benefit of those improvements. And here, this system's already up and running. The next one looks like it is about to come through and do the same process. And I waited to show you this because I do want to show you how to recover the systems and come back through. You'll notice we're getting the same status update and watching the activity flow through as it goes through its post-provisioning steps. So that's looking great. If I come back to this first one that it completed, this is machine 100. I can come back in here, and I'm going to put this on screen so you can see it as I go through. I'm going to go back. Let's see. I don't think I can keep this on screen exactly for you, but I'm going to go ahead and rediscover this machine. If I click finish in here, it's going to immediately start the process to bring that machine back into Digital Rebar Sledgehammer, and so you can see it automatically rebooted, and it's going to be booted back into Sledgehammer. One of the things that's nice about Sledgehammer is it's highly optimized, so getting back into Sledgehammer is very quick. We're not installing a full operating system. We're just going to come right back in to Sledgehammer. You can see it's just about finished. That boot process, there you go, it's already in, which means that the system is now going back through its post-provisioning process and checking in, updating, getting ready for whatever the next actions would be. And that could include scrubbing the disks, resetting the RAID and BIOS, changing inventory allocations, whatever you need to do to make the system work. So this is a quick tour of how to set up and install Digital Rebar, sort of taking you through the bumps along the way so that you can see exactly what you need to do to get your own trial running. If you want to just see the condensed version, or if you want to share this with a friend, we do have that smooth sort of run through that skips all the troubleshooting pieces like that. And if you need any help, do not struggle with these installation processes, especially as you get into real metal and away from VMs. call us. Our customer success team is here to help answer your questions, guide you through the process, make recommendations to streamline your digital rebar experience. There is no more comprehensive and complete bare metal infrastructure management platform on the market than Digital Rebar. And we're looking forward to you having that experience in your own data center.